Okay, this is the latest problem that we've got. The steering packs and the battery holders, these are supposed to be heavy enough to control the steering. Basically what it's got to do is shift some of the weight from one side to the other, and it does it from tilting like this. The battery weighs about 350 grams and the servo is another 50 grams on top, probably about 20 grams worth of plastic. So yeah, what I've done, I've had to come up with another solution. Because it runs fine off just one battery, we're just going to use just one. And then for the other one, it's just going to be a weight. So what I've done, I've worked it out. There's 140 1p coins. Each 1p coin weighs 3.5 grams. So times that up, it's about somewhere around 490 grams. So what I'm doing is I've got some of the 1p's up here ready. That's just the new bracket. That's like what that blue one is, but there we go. Yeah, so if we come over here, we've got the 1p's. So they're in stacks of 10, and we need obviously 14 stacks of these. I've only got 10 here. And I'm going to tape them all together, and then that's going to go like how this battery is on this bracket. And then this bracket will go on the other side of the internal parts. So we got one that's going to go on this side, and I haven't drilled it out yet. There's going to be one on this side and one on this side as well. So as it's going, forwards, these brackets are going to be able to swing left and right. And I've also got a Servo Reverser as well. So because these servos are going to be facing different directions, they're going to turn in different directions, and we need them to turn in the same way. So we've got this Servo Reverser for that. It's an easy solution, saves having to put an arduino on it just yet for the testing stage. And that's it for this part. Okay, this is the almost finished weight pack. You can see all the 1p's have been taped together. I weighed it, 515 grams it was in the end. So with all this, the servo and the bracket, it's probably, I wouldn't say it's 600, maybe 580 grams. So anyway, I've just got a couple more bits to do. I need to put the servo part on, and I need to make a gear for it, and then that's ready to mount inside. Here is the BB8 internal mechanism. It's all fully assembled now with all the new parts. I've managed to shave off about 40mm along this axis here, which is the drive side, which gives me a good 20mm each side for putting on other stuff like a sensor, and I want to have a rotary connector as well, so I can have cables going from this part to the outside shell part. Here is some of the old parts. This is an old battery swinger. So you can see there's the new part. This is the old part. There's quite, try and line it properly so you can actually see. There's quite a lot of difference. I think there's about 16mm, and I've managed to save off by shortening the gears as well. There's quite a lot of difference there. And also even on these parts for the head, that used to be like that, so it's sticking out really far. I've put that part onto the servo now, so the gear's like that, and then I've managed to chop this piece off, or at least some of it anyway. I need to have some of it open so I can still access the grub screws to tighten it up. And here is the other bracket for this part here. So again, this one's 10mm shorter. So that was to give us the 20mm either side. So we had to shrink this down, and we had to shrink that part down. Originally, well, for the testing, we've been using a radio-controlled car speed controller. That one here. It's a little bit limited. I've got the steering settings on maximum on the control, and it's still not turning enough, so we're going to have to be upgrading to use the Arduino. So you can see all these pins on here. I'll be able to connect loads of stuff up to this. So that's going to be on top, something like that, or like that maybe. And then we've got another speed control as well. That's going to be for the motor, which is this thing. Can't remember what it's called. Yeah, it's got a name. They're quite common. They're really cheap on eBay. This is about £2.50, something like that. Arduino Mega, I think this is about £5–6, and then Sensor Shield another £3 or £4 on top. So like these electric parts, they're not that expensive. I tried doing some testing earlier and didn't really go too well. Well, we've got Servo Reverser, so like we was able to switch the steering over, so both bits were going at the same time, which is quite good. Yeah, I was just tightening up on the shaft, it was slipping quite a lot, and then because the ball's still missing panels, it's obviously not going to roll very well. And I got all these loose cables at the moment, so I'm going to have to do something with these as well. To try and tidy it up a bit, just so none of it gets stuck in the gears or anything and munched up. So that's it for this part. Okay, here we are with all the internal parts installed. I haven't fixed in the shaft yet, and I haven't programmed the motor controller, but I've managed to program the steering servos quite easy for use with the radio control car receiver. You can't really see it very well, it's a bit dark. So we got the battery pack, that's powering the Arduino Uno and the sensor shield. It's all connected up. So yeah, this is how it is. So we turn the steering on the handset, and it leans the servo over. So have a better look. So we got the servo and the battery and the weight all leaning over at once. It's resting against something at the moment, so it's not going to tip over, but I'm just going to flip it the other side and then try and catch it as well. So you can see it's got quite a bit of tilt on it. How it's gone into the circle part at the bottom. That's why it's stuck. So we'll just tilt it back again. Right, now this time I'm going to tilt it the other way, so you can see how much force it's got. And come on, there we go. So you can imagine if it's rolling forwards and it's tilted over like this, it's going to do quite a tight circle. There we go, it comes back to the middle again and I let go, and then over this side and that way. So it's working really well. You know, it only literally took about 10 minutes to this code. It was just a modified part of code from an Arduino controlled radio control car that I made before. So that's it for this part. There's not really a lot more testing I can do now until I can wire up the motor controller, which is just here. That's not going to take long, for about, I'm not sure, maybe about 10 minutes, then adding it into the program, connecting it to the throttle on the handset. There's also something I want to try as well, and with these steering servos, they're both going the same way, so I want to see if I can make it so that one can go one way and one can go the other way when we operate this switch here. Which it sounds a bit weird and kind of pointless, but what it'll be able to do, you'll be able to swing both of them opposite directions fast, which will make the robot twist a little bit like that. So if you spin them fast one way, and then slow the other way, and then fast one way, slow the other way again, you'll be able to turn around on the spot. So I'm going to try and incorporate that into the program. Okay, and that's it for this part. Here's the next part. I've connected up some more things, I've done some tidying up on the cables. The speed controller, that's all set up, that's all programmed, all uploaded and running. So it's all connected up to the throttle on the handset. So we got forward and reverse, and it's fully proportional as well. I had to do a lot of mapping, mapping out different parts of the throttle position, stuff like that, because from all the way reversed to all the way forwards, that's the 180, and I had to get it, it's too complicated to explain, I'll show you in the code after. So if we go for the forward throttle, I'm going to start slowly. So you can see it's turning quite slowly, and then put a bit more throttle on, and we can go, no, that's fast as it goes. You can't really tell the speed change so much for this. It's like fast and slow. But obviously when it's turning the whole ball, the difference will be a lot more noticeable. So we've got reverse as well. Okay, so we've got forwards, reverse, and we've also got the steering. Ooh, don't want to do that. But that steering thing, as I mentioned before, I've connected up to this little switch here. So now we can have normal steering, where it turns the battery and the weight, or we can have opposite steering, so we flick the switch, and now they go opposite directions. So I'm not sure if this is going to work or not, but at least we've got the switch, so we can just switch it over. So it's not really a problem, and it's not taking up any of the space which other features could be. So that's it for this part. Okay, not sure if you noticed on the last part we was having some power issues with this. We were using the USB battery pack. As you can see, it's only got a 1 amp output, which isn't quite enough for powering 2 servos, lifting a big battery pack and a big heavyweight, and a speed controller, and an Arduino shield, and a radio receiver, and any other stuff that's going to be attached. So what I've done, I've changed the plan. We've gone onto a 4-cell battery pack, so this holds 4 AA batteries. The output for these batteries is probably, well, I'm just going to guess, I'm just going to make it up because I don't know it. We got a 2 amp output on this. I'm pretty confident that it can deliver that sort of power. So all I've done, I've just stuck a switch on, wired it up, connected it up, put a little removable connector on here, and then we've got another connector coming out of the shield. And there's also a piece of Velcro on the bottom of this and a piece of Velcro on there. So what we got to do is stick 4 batteries in here now and stick it on like so, onto the Velcro. I mean, it's not brilliant, but it'll do for now. I'm probably going to 3D print some kind of box that this can slide into, and then I'll have it more over here in the middle, so it's better weight distribution. But for now, this will be fine. So I can disconnect it and I can turn the power on and off without having to do any screws for wires or anything. Okay, that's it for this part. Okay, this is the final part to the pre-ground test. So we've got everything up and running now. We've got all the shafts connected up to the main body, and all the steering's working, the throttle's working. So it's all on the radio control, so if we just give it a little bit of throttle, and then go back reverse, throttle again. Okay, and test the steering. So going one way and going the other way. Okay, everything seems to be working fine. I've also added these little metal pieces here just to help hold this part on. It gives these orange bits a little bit of support from the inside, because it's only supported by these parts at the moment, these little biscuit parts. So I've just got a couple more little bits I want to do. I'd like to charge the battery a bit as well. And then